Hello, grade 10s. Hope you guys are doing well. I'm going to give you a little lesson today on writing word equations. We touched on this Friday, but I just wanted to review it a little bit, get you thinking. I know you've had a weekend since we first reviewed that, and I think it's important for Miss Morris to know what my expectations are for your ability to write these equations as well. So this is for you, and hopefully you have your data book out in front of you. We're going to be doing page 66 from your study guide. So have this page 66 out in front of you, have your periodic table out in front of you ready to go, and we'll go through a few examples together, get you warmed up, and then you're going to work on these on your own. My period 2 class, you guys got to practice Bunsen burners. Period 5, you did not. I'm not able to do that today with you, period 5. So hopefully I'm back tomorrow, and at the start of the lab, we'll talk about how to use the Bunsen burners, but that's later. Okay, so you've got page 66 out in front of you. You've got your periodic table out in front of you. Get ready to rock and roll. Here we go. Okay. Oh, and by the way, on this worksheet, it says balance the reactions. We're not going to do that. We're just writing out full chemical equations with correct states. All right, so first one, solid sodium metal. So sodium is an alkali metal. It's not diatomic, so it's just Na. We put down its state. It's telling us it's solid. Reacts with, there's our plus sign, chlorine gas. If you put Cl for chlorine gas, that would be wrong. Chlorine gas is diatomic. Remember, all the halogens dance in pairs. They're part of the 7 diatomic elements, starting at number 7 in the shape of the gun. So you cannot forget that, or it will mess us up on balancing. Okay, sodium metal reacts with chlorine gas to produce, there's our arrow, solid sodium chloride. So this is ionic compound, so we need to figure it out. Na is a plus, Cl is a minus as a cation and an anion. So crossover method gives us NaCl, and it says it's a solid. How easy was that? Okay. Any questions? If you do, you're going to ask Miss Morris after the video. Okay, second one, solid potassium metal. So you look it up if you've forgotten potassium. Solid, it is not one of the diatomic or polyatomic elements. It reacts with oxygen gas. Oxygen is diatomic. If you write O, it's wrong. Oxygen always exists as O2. And again, similar to the top one, this is an ionic compound made up of K plus. For potassium, oxide is O2 minus. Crossover method gives us K2O solid. If you suffer from a little bit of OCD and it's driving you crazy that these are not balanced, you could go ahead and balance them, but again, you don't have to yet. If you're watching me do this and going, I'm not ready, don't worry. That's fine. We're going to practice balancing on Wednesday, but if you want to go ahead and balance these ones, you can. It's optional. Okay, let's see. I'm just taking a look here. Sure, let's do this one. Hydrogen gas. Hydrogen gas. How did I do? I know, terrible. It's diatomic. That's better. Reacts with oxygen gas to produce liquid water. You can write raw water as H2O or HOH. They're both acceptable, and it is a liquid. And I'm not going to balance it, but you're welcome to if it's driving you crazy. Okay, let's try this guy, H. Mercury 2 sulfide. So Roman numerals, it's multivalent. It's telling us we're working with the mercury 2 plus ion. You look up sulfide and it's a 2 minus. Okay, so correct formula for mercury 2 sulfide is Hg2S2, which reduces to HgS. Okay, it doesn't give us the state, it just says it's decomposed. So does it say anything in here about it being a solution or being dissolved in water? No, it just says mercury 2 sulfide. So what would be the state of an ionic compound if it's not in solution? Solid, liquid, or gas? Every ionic compound is a solid. It's decomposing into liquid mercury, which is not diatomic, and solid sulfur. This one's tricky. Sulfur, solid. How did I do? Terrible. Again, sulfur is polyatomic. Its most common form is S8. And if you've forgotten all of these ones, you have that little table, I think, that gives you the polyatomic elements in your data book. So beware of that. What else was I going to do on this one? Okay, so this question I'm going to change to potassium chlorate in solution decomposes into oxygen gas and potassium chloride. So we're changing this equation by adding water to it. So what would it look like with states? Potassium chlorate in solution. What does that mean? So first of all, let's get the formula. K plus, chlorate is ClO3 minus. So correct formula is KClO3 in solution. How do we show in solution? That means dissolved in water, aqueous. Decomposes into oxygen gas. Oh, this is in water. Does it matter if oxygen gas, do I write that as aqueous or do I leave it as a gas? What do we do with elements in water? Do you remember? Elements in water keep their state. So on the periodic table, oxygen is a gas. In water, oxygen is also a gas. Okay. And potassium chloride, so that's K plus, Cl minus, KCl. Okay, what do I do with potassium chloride? This reaction is wet. It's happening in water. So what do I do with ionic compounds in water? I need to go and look it up. As this forms, is it going to form a high soluble or low soluble compound? So we need to look up solubility to see if it is very soluble, which will make it aqueous, or low solubility, which makes it a solid. So go look it up on your solubility chart. And you discover that it is very soluble, so we're going to write aqueous. If it was low solubility, it would be a solid. Solids for low. So you have to pay attention if water is present or not. Now you guys have a list in your notes. I should have snapped a photo of it. That gives you a reminder of all the things you have to look out for when you are writing out these chemical equations. The polyatomic elements, solubility for ionic compounds. What else? Solids for ionics when they're not in water. Elements keep their state when they are in water. All those things that I just went through is in that checklist in your notes. So now you guys are going to get a little bit of time to work on the rest of this page, so 66 and 67. Then I want you to jump on to the next pages as well, so 68 and 69, 4 pages of writing chemical equations. And then in the second half of the class, you guys are going to be getting ready for the large lab you're doing tomorrow, and I will have a short video on that as well. Yay, something to look forward to. Okay, good luck, and you can start working on those unless Miss Morris has some things she wants to add.